Hey everybody, this is Larry, this is me going Q3 of the weekly contest 431 maximum coins from K consecutive bags. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So there are a lot of ways to do this one. I think the canonical way to do this one is with sliding windows. The key thing to note is that there are only a couple of interesting points, right? What I mean by that is that, and I'm going to bring up the drawing thing, so hang on a second. Right. It's kind of funny because I have on screen from the daily problem, and it's very similar, right? So basically, the idea here, though, I don't. Let's just draw it afresh anyway. So the idea here is that we have. Am I not plugged in? Oh, I'm always holding the mouse, the pen well. But yeah, so you have a number line, right? Ooh. It's very sensitive. I need to readjust this. Maybe I pressed the wrong button, something. Anyway, yeah, I don't know how to adjust this sensitivity. Okay, I just have to write more carefully then, and then I have to fix this somehow. But yeah, so, sorry, like I said, the sensitivity is really wrong. Maybe the, oh, I know why. Right. Oh, wait, no. Sorry, friends, technical difficulty. Dealing with a new thing. Okay. Okay, so, alright, that's better. But yeah, so basically you have a number line, right? And you are, you have just segments of coins, right? And technically this is on the, oh no, this is on the number line. So the key thing is that you have a number line, right? And you have basically a lot of different segments. And of course, these are not indexes on an array. And what I mean by that is just that you cannot do, like, you cannot keep an array and just do a difference array or something, because that would be very simple. Then you just do a prefix sum. But the idea here is that it is trickier, right? But you can still use the sweep line algorithm here. The idea here is that, okay, so you have a sweep line, you go from left to right, and then here we just want to adjust, for some k, that is the input, the sum of all these things, right? And then as we sweep, we want to, the nuance about this is that you don't always only sweep on the beginning points and end points, which you normally would. You also need to consider this k, so then the event is that the end border also lines up against critical events, right? For example, let's just say this is critical, and then you have this thing as k. So you have to line up this way so that the sweep line is a little bit different, right? So here is in the middle technically, but because of the right side goes against k. But the reason is because the answer can only change within these critical events, right? For example, let's just use a very silly example of k is equal to 2, right? Because if you have k is equal to 2, right? If you have k is equal to 2, then let's say you have just like here, right? Let's just say this is k is equal to 2. Then of course, if you kind of see that it gets boxed in here, and then even if you move it 1 or 2 to the left, it doesn't change anything, right? Because literally nothing interesting happens, because otherwise you'll be on interesting points. So those are the only critical points. And as a result, if you kind of look at this, if you I have to move my hands a little bit so that's on the window. But just sliding window, right? Just keep on sliding, and that will get you the answer. I'm not gonna lie, I didn't solve it this way. The reason why I didn't solve it this way is because I thought that this would be way tricky to implement. And the reason why this is tricky to implement correctly is just that, I don't know, or maybe not that hard, but just that it's way easy to make mistakes, right? And maybe I'm wrong on that, but I just feel like that's to my ability. And as a result, and when you make mistakes, it's just harder to debug, because you have to keep track of all the previous states and then the changes to those states to get the sliding window. So what I did instead was, if you look at here, oh, I guess I took it off. If you look at this graph, I just look at all these interesting lines that we draw that we have to take care of, right? And then at those points, I just do a binary search of, okay, well, we have this thing. So then we binary search for the right side, and then we just do the math, right? And the math is just taking all these chunks. So you have prefix sum, right? So the way that I did is with prefix sum. So let's just say you have a lot of intervals, right? If you have prefix sum up to all these interesting points, right? So for example, this is an interesting point. So you have a prefix sum going up to here. You have a prefix sum going up to here, dot, dot, dot. And I'm not going to go over prefix sum for this video just because this is already going to be long. And then here, then if we try to find this k, then it is just this point, this prefix sum of this minus prefix sum of this. But then now here, you can see that there are a couple of cases. One is that, maybe this is in the middle of this. And then if this is in the middle of this, then you just have to do the math on this chunk, right? If it is in the empty space, we also have to do the math, but not that much. So that's basically all the, like case analysis complexity. I know I'm going really fast, and the reason why I'm doing it a little bit is because I'm going to go over it in code. But really, in that way, it is just case analysis. But yeah, okay. And yeah, and here I keep track of a lot of things, keeping in mind that you're also given c sub I, which is kind of like the height of the you can also think of it as like k different segments on the same line or something like that. But if you want to just think about it as one line segments, but that makes the problem a little bit more complicated, but not super impossible. So yeah. So okay. So basically that's how I set up the events, right? Actually, I don't think I do end up using this to calculate the height, but yeah. So basically, this is the sweep line idea, is that, okay, the sweep one line segment begins at L, or C of them if you want to call it that way, or the height of it. And then on the R+1, we remove C, right? These are basic difference array things. Definitely very tricky, but yeah, right? Yeah, and then now I look at all the keys, and I just added a sentinel value of 0 so that we don't have to worry about weird things. But yeah, and then now for every pair, I use this to calculate the length, right? And what I mean by that is that between every interesting point, I just calculate the length so that allows me to calculate the prefix some easier way. Though I guess I didn't really need to, because technically I used it like this here. So maybe I don't really need to do this. So let me actually update this really quickly. I think this is slightly easier to read if I update it, because I think there's a little bit of abstraction there as a result. So I can remove this, I think. Let's run it real quick and make sure that I'm not lying to you. Yeah, okay. So we didn't really need the length thing, mostly because because we can calculate it anyway. But then for each, so this is for prefix sum, right? Oh no, I skipped something. So we have to get the height, and then the height is just basically calculating the result of a difference array, right? So Y is already sorted, is all the X values, and for X, then we now basically for every event we either add or subtract the height, so then you get the new height of the upcoming rectangle, if you will, because we needed to calculate the area, which is the total sum of the coins over that interval, right? So then prefix sum, then now the prefix sum at X is just you go to the previous prefix sum plus this is the length of the X, and the previous X will give you the length of the rectangle, and height will give you the height of the rectangle, and again we call that the area of the rectangle as a visualization is going to be the number of coins within that area. Yeah, and then we just kind of update previous, and then we update the previous X. Probably could have done this cleaner, but whatever, right? And then now that's pretty much it. So the idea here, and there's a bunch of probably repeated code, but the idea here is that, like we said, for X, and I kind of separate them as two functions so that I don't have to worry about edge cases as much, because they're very specific. And there's two cases, right? This is one case and this is second case. And the idea here is just to bring the drawing back up again, or maybe a new drawing, is that there are two cases, right? So given, let's say you're trying to figure out an X, and then x plus k, right? I mean, I was kind of lazy, actually. Okay, maybe actually this is a little bit wrong. So let's say we have a sweep line. We are at this event. So then now the two things we have to care about. One is that given that this is x, we want x plus k here to calculate the sum of all the things. And then also x minus k for when we go from the left side, like we said about. So this is x minus k. So to calculate the other case where the endpoint is on an interesting line, right? So the left side is on an interesting critical point, or the right side is on a critical point. Those are the only two cases where things can change. So that's basically why we have this thing here. And of course I just made it max into 1 for sentinel values, and because so that you cannot go, you can't just go negative. It doesn't do it. That's not part of the input, so it will always be 0 on to the left of 1. So that's why. But yeah, and then for the left, it's just that. Okay, so why do I do it this way, right? So bringing it back up to visualization is that the interesting point will always be the way that I structured it anyway. The interesting point is that, okay, given a number line and you have all these different segments, right, and maybe even different heights of a segment, right? And you can even think about it in after we processed, then now this will give you a height, right? And then, something like that, right? As part of the height thing, right? And maybe it goes to the left side too as well, right? Let's just go all the way, right? And maybe I should go a little bit more. And let's just pretend that this is right here, right? Well, so I just kind of, instead of doing more if statements, the way that I thought about it is that here, this is always a critical point between intervals, right? But then, so that means that here it's going to be full, and we could just do a easy prefix sum on the left side. Here, we just binary search for the next or the previous interesting point. So then we could do a prefix sum, and then because we have two prefix sums, then that will give us this answer. And then now we just have to do extra work on this little thing, which we all know the height and we know the width, or we'll show you anyway. And then on the left side is the same idea, and this is not readable. On the left side, this is the same idea, right? So it's x minus k. So the thing is that this could be on a breaking point as a result. Then the last interesting thing, maybe it could be here, right? Oops. It could be here. So then now we calculate the prefix sum from here to here to calculate, this thing, right? So then as a result, we just have to calculate this thing, which is what we do. But yeah, so then the left index, you don't have to do it this way, but I thought it's a little bit easier versus like other if statements. Like I said, maybe you don't need to do it this way because this is the same. Maybe you can, but I just didn't want to, I feel like it's easier for me to debug this way. But yeah, but left is taking out and is taking a partial sum, right, of a chunk. And then on our clock, it is the opposite, right? On the right. So yeah, so then here you can think about it that way, like I said. So this will always be exactly, well, this will, because, yeah, I think it's just thinking through what bisect left does and binary search does. But now that you search for left, this will give us the next, because a binary search will give us exactly the next element, even though it could be exactly on an element. So this gives us LX, and then the previous LX is index -1. And the reason why we need the pure LX is so that we can get the height, because that's where I store the height, is on the previous X, on the beginning of a segment, right? Or beginning of what I call a chunk. So yeah, that's pretty much it. So we know that our index, so then here we have the prefix sum, which is the stuff that we talked about. And here's the left chunk sticking out on the width, and the height. This is why we need the previous index or the previous X, and that's it. Yeah, and that's it for the left sticking out. And the same idea goes for the right. You can kind of, I'm not going to, it'll be homework for you to figure out why the binary search works exactly. But yeah, but this is the prefix sum chunk, so we don't have to do work. And then this is the right side that is sticking out. And that's pretty much it. As you can see, this calculation is log n. to log n viewer, and this is n O of log n. So in total, this is 4 log n for each event, and there will be at most 2 events per n. So there's gonna be like 8 times n log n or something like that or whatever, but n log n regardless. So that's pretty much all I have for this one. That is the idea. Let me know in the comments if anything's confusing, or you know, you have a question more specifically. I mean, just saying that something is confusing maybe helps me. I don't know, maybe it does, but it definitely doesn't help you being unconfused. So just ask a question on what you would like to understand. But that's all I have for this one. Let me go through the code one more time very quickly. Yeah, I set up the events, I set up the heights, I set up a difference thing on the events, and yeah, I add the sentinel, but I add the list otherwise. This is setting up the height, the summation of the height of the difference array. I set up the prefix sum here based on the height and the width based on the previous x, and then again we just brute force or like sweeping over every interesting x, doing a binary search on the left and on the right as a result. And that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me solve it live during the contest now. Okay, what a silly mistake. Just misread it. Or like I was looking for it, but then I don't know. Okay, focus Q3. You could come back on this. Silly mistake, but okay. Coins. They're not overlapping. K consecutive bags. I guess the numbers are big as Y, but why is this hard? What's C sub I? C sub I 1,000 coins. Okay. These are all big. I mean, it's not that bad. I just have to figure out how to be careful about adding all the segments. What a silly mistake on the other one though. I just misread it and I rushed it as a result. Sad face. Okay, so yeah, it can go beyond that, right? And it can go to the next one. So it's sliding windows, but it's a little bit sloppy, I think. But a lot of people are getting it wrong. I mean, the segment part isn't that part, right? So okay. Let's see. Right. We can also just do binary search, I suppose. That's not so bad. Yeah, I mean, I think you have. Well, you don't have to. You could do 2 pointers, but well, I guess you don't sort this, but. That's an annoying 2 pointers. Can I do prefix sum in a smarter way? I mean, that's basically what this is doing here. A lot of people are getting it wrong though. Anyone self Q? More people self Q4. But I think you're supposed to do prefix sum on this in a smart way. Because you can compress all these things. Does it matter? Okay, maybe I can do something with it. Okay. I think it's pairwise library. Okay, fine. Try to learn something new, or they'll be consistent about it. Okay, so is that right? Let's say this one, so then so if L is equal to right, then it's gonna be 1. And that's true, so okay, fine, that's fine. So, okay, and then now we can do something like and this is so annoying. What am I doing? Focus. You know what you want to do, Larry, just do it. Oh yeah, what am I doing? Focus. Focus, focus, focus. So what I want to write. Okay, why would you think you want to write and then modify it? Okay, fine. Right then, inferior prefix right? Instead of doing it in my head. So okay, so it's this, but it's not quite right, right? This is this plus this times length. So then actually we want, okay, so previous is equal to 0, right? So actually then now x is going to be equal to the previous plus length of x. Oh, I'm going to sweep the event to get the height of h. That's what I was missing. Okay, fine. Right. Height of x. Okay. Right. So now it's okay. So that is the prefix sum, right? Oops. Prereqs. Okay, so then now we have this. Now we can solve this with 2 binary search in theory. How do you do? Okay. Inclusive, right? So that's a big function, and then we just do a scan afterwards. Scan is easy. So then now we have to find the index. So then prefix. Maybe the print prefix just for science. Okay, let's see if this gives me something right. height. Oh, height is equal to current. X length. Do we not do length? So this doesn't do the last element. Last element is going to be 0, I guess. Okay. Is this right? This is 30 and 11 it is 30. Okay, that's prefix. That makes it right. 6, 6, 15. Okay, that's probably right. Need to draw it out. 1 to 3 is 2. Okay, so that's not 6. That's 6 because it's 1, 2, 3 times 2. Okay, 6 at 4. So that's in okay, let's also print height. People are having trouble with this one, like I am really. So it's good because that means that you should take your time, right? Okay. Don't rush it. Just get it right. Okay, in there. So we want to bisect the events of left. So then now we want to find the number that is smaller than it to get the height, right? So index is equal to this. Index minus 1 if index. So if it's not found, what happens? So if it's not found, then the left is the smallest number, but that shouldn't be possible. We won't start with the smallest number anyway. So okay, so maybe we're good there. Okay. No, because then it could be exactly the same. Exactly the same, so we want bisect right. Okay. Okay, so then now left, right? And then now we want to left in, this is left index. Okay, so then this gets us the height. Well, left index is just the index, so then left x is just equal to e of left, and rx is equal to e of right, maybe. I don't know if I need the left one, but the left x is just the prefix of rx minus prefix of rx, because it basically contains all the stuff in between. Okay, right? And then now we have to calculate from rx to the next number, so then it is going to be rx minus right or right minus rx for the delta, and then times the height of rx. So we add this, and then that should be good actually. Yeah, and then now we just try for x in y. Best x, what's it called, calc x and x plus k, and we should be good. Yeah. Yeah, I need to, I don't know if that's an optimization, but nonetheless, e of right. Oh, e of right left index, minus 1 actually. That's why you asserted it. 0, 6. Okay, the 6 is great. Love the energy. This is wrong though. Why do I get 0? It's good that we get it wrong here, but okay, so we start at 3, right? Okay, so let's see. Okay, negative is probably not right. Did I do the thing wrong? Oh, right, yeah. Why would I write it this way? Huh. Silly Larry. 11, 6. Okay, I mean, it's wrong, but off by 1 is okay. Maybe not. Okay, so we start at 1. If we start at 1, we have 8. Is that right? No. Yeah, I mean, maybe actually. 1, we have 1, 2, 3, 4. 1, 2, 3 is 6. And then 4 is 0, right? So 8 is definitely wrong. So we're definitely finding mistakes. This feels wrong though. I feel like I'm off by 1 somewhere here. That's why on the indexing. Actually, this is 6, so that's fine. But height of Rx is wrong, maybe. Okay, so prefix sum is maybe right. Yeah, I mean it feels right, but I don't know. Maybe I'm off by 1. Okay, so 6, 6. Where do you get the 8 from then? This is 8, even though... Oh, 14 and 6. Okay, so I misread this. So 14 and 6. Okay, let's take a look at the prefix. This is definitely wrong. So we want to go from 1 to 5. Oh, 5 is a number, but 14 is wrong. As a prefix. No, yeah, this is wrong. Why is my prefix wrong? To length times height? No, that's not right. Height is not updated yet. Because you wanted to prefix, right? So this is the previous x, right? Is this from 1? Okay, so it's 1 indexed. I think this is okay. Oh, I didn't update prefix is equal to x. Okay, well, silly mistakes. Okay. 0, 4 is 2 as well. Length of x. Oh, this is length of previous x. Yeah, I think I'm just off by 1 on the indexing, honestly. I spell length wrong. Length and height is so confusing looking. Okay, so at least now this is right. 0, 6, 5 is okay. So this prefix is finally right. Okay, so 6. Okay, so then we are undercounting, which is fine because that means that we have an opportunity to fix and not just a bug. 11 should be at index 3. So what is my index 3 saying? Oh, we don't start at index 3. That's why. Okay. I thought that it would be at the beginning of stuff, but clearly it can also end at 1. It's an important factor. Okay, so that means that we have to do something like x minus kx. But but our formula is wrong with this. So let's see. Yeah, I think this is wrong for that. Which is fine, maybe. We just need to we just need to add a 0 to it. Nothing, not a big issue. Maybe. Okay, so this tries to go to a negative number as a result, right? But also this is just wrong anyway, so let's just call it right calculate. We'll copy for left calculate. Okay. One code real quick. Yep. 35 pixels down it, so it's still kind of tricky, but it's okay. Yeah. So this is left cal. And let's just say right cow should be right. We just have to think about the left cow. It's not that bad. But yeah, this is no longer true, I don't think. So yeah, so it could be negative, but we can also just do max of this to 0, because I don't think that matters. Nothing happens before. Right now, right? So 14 and 4 is definitely wrong. How do you even get 14? It doesn't even. Oh, there it shows 14 is 3 to 7. I guess, yeah, ends at. Yeah, okay, I think that's fair. 3 to 7 is 14. Why? 7. Oh, 3 is 0, even though it should be 4. Okay, so then now we don't want this. We want bisect left, and then this is right? So then if it's exactly the same, okay, so then now, how about the right side? If it's exactly the same, we still. No, and the right side should be exactly the same. So here we should just index left because it's just exactly the same. Should not need to do that, though. That wouldn't have been wrong, but I think we just, it's not necessary. Okay, so then now we want to say okay, so the prefix should be right still in this case now, but then this thing is wrong. So then now it is going to be, okay, so it is going to be the next one. So then now Lx minus left times height of L, now Lx minus 1, I want to say. Yeah. So this part I feel like we have to do something, but y being 0 should fix that, but I think maybe we just have to do it to 1 and it should be fine. Yeah, I mean, we could also add another sentinel, but I think this is fine. And then it's PLX, right? Oh, that's just. Okay, 10-6. I think we're Gucci. Let's double check the math though. 3-7. 7 is where it goes 10. I mean, I'm printing weird things, so that's why. Lx minus left. It's okay. Not that many people solve this. You can take your time, an extra minute or 2. It's not a big deal. Okay, so you have one space left over. That is right, I think, because it goes from 7 to 3, and 3, this is 4, okay. And yeah, okay. I mean, I don't know. Am I confident about this? It's very easy to have it off by 1 on this. So that's why I'm not super confident, honestly. But it's good enough for me to YOLO. Yeah, okay. Okay. Now we're in business. 30 people solved it. I've solved Q4. Let's see, what's the leaderboard doing? Okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.